All right, now question 2 on the 2018 free response was an interesting question. It was an environmental science teacher at a school with a large population of students wanted to estimate the proportion of students at the school who regularly recycle plastic bottles. The teacher selected a random sample of students, and each student went into the teacher's office one at a time and was asked to respond yes or no to the question, do you recycle regularly plastic bottles? Based on their responses, a 95% confidence interval for the proportion of all students at the school that would respond yes was calculated to be between 0.584 and 0.816, which means that they're about 95% sure that the true proportion of people who recycle bottles is between about 0.584 and 0.816. So part A says how many students were in the sample selected by the teacher, which is a confidence interval working backwards problem. And if we remember anything about confidence intervals, the formula is take a point estimate, a starting point, and add or subtract the margin of error, which for proportions is z star times rad p hat q hat over n. So what do we know already from this? Well, we know the critical value for sure, right? We know that's 1.96, and because it's a 95% confidence interval for a normal curve, okay? And then how do we get this p-hat? Well, the interval is from 0.584 to 0.816, so if I do 0.816 minus 0.514, I find out that those are 0.232 apart. And if I take that and halve it, that's going to give me my margin of error, which is 0.116. So I get 0.116 is my margin of error, or that right side there. Now, a couple other things. If you want to know what the point estimate is, which I don't know if we have to, but you could do 0.816 minus 0.116 or 0.514 plus 0.116, and that'll tell you 0.7. And then this standard deviation, well, actually, yeah, we did need that because now we know it's rad 0.7, 0.3 over n. And we know that this whole right side has to equal 0.116. So it just becomes a little bit of algebra here. Since the margin of error, this is our margin of error is 0.116, what we add and subtract. So I'm going to set my margin of error. Let's pick a different color here. 0.116 equals, well, it's 1.96 times rad 0.7, 0.3 over n. And we're going to do some algebra here to solve for n, right? What can we do? Well, we can divide this side by 1.96. And then we get, let's see, we get 0.116 over 1.96 equals rad 0.7, 0.3 over n. We can square this whole side, we can square this whole side, cross multiply and solve, and eventually you will get n equals 59.9, which means they're most likely, we can just say 60 people. Okay, good. Now, part B says, given the method used by the teacher to collect responses, explain how bias might have been introduced and describe how the bias might affect the point estimate. Okay, well, a couple things. It's very nice of them, again, to say the second part, which was describe how it would affect the point estimate. This is something that if they don't tell you, you have to do anyway. Identify the bias and in which direction. So what did I write for B? I wrote, there might be bias since the teacher who is an environmental science teacher asks their own students the question. The students may have felt more obligated to lie and say they do regularly recycle even when they don't. Now, I didn't say this would lower the point estimate, but I am saying it in a sentence. Now, part C. Part C is a little strange, and it might take a few read-throughs to kind of understand what's happening. I'll do my best to explain it. Part C says the statistics teacher at the high school was concerned about the potential bias in the survey. So to obtain a potentially less biased estimate of the proportion, the statistics teacher used a different method. And the method they used was this. They took a random sample of 300 students, and each student was given the following instructions on how to respond to the question. Now, they were told, flip a coin. And if it's on your own, flip a coin. If it's heads, when you walk into the room, you have to say, no, I do not regularly recycle, even if you do. So if you got heads on your own, don't tell your teacher, you say, no, I don't recycle. If you get tails, then yes, answer the question truthfully. Yes or no, depending on whether you do or don't. So part 1 of question C, sorry about that, give me one sec. Part 1 of question C says, what is the expected number of students from the sample of 300 who would be required to respond no because the coin flip resulted in heads? All right, great. Well, part 1 is nice and simple. Part 1. We would expect, you can kind of guess this, well, what's 0.5 times 300? 150 students to be forced to say no. Okay, so part 1 is nice and easy. Part 2 is a little trickier. Part 2 says the results of the sample showed that 213 of the 300 selected students responded no. Based on the results of the sample, give a point estimate for the proportion of all students at the high school who would respond yes to the question. So what I wrote was this. I wrote, if 213 answered no, and we expect 150 to be forced to say no, then I just did a little quick math. 213 minus 150 is 63. So that means 63 people who said no were truthful. So out of the 150 who were allowed to answer, who didn't get heads, the ones that were allowed to give their right answer, 63 truthfully said no, not because they were forced to. So 150 minus 63 is 87. So 87 of the 150 who were allowed to answer truthfully said, yes, I do recycle. Well, what does that mean? So that is 87 out of 150 will be our truthful p-hat, which is 0.58. And that's a tough one, so read through it again and see if it makes sense, and if not, we'll discuss it later.